Today we work with solving systems of equations by the method of substitution. Looking at this first system, 2x plus y equal to 6 and negative x plus y equal to 0, our first step is going to be to solve one of the equations for x or for y, whichever is of your choosing. Which equation you choose and which variable you choose is ultimately up to you, but when we look at a problem like this, sometimes one of them will lend itself a little bit better. And in our case here, this negative x plus y equal to 0 lends itself a little bit better because both of the x and the y have coefficients of 1. In the case of x, negative 1, but that makes it even better when it comes to solving it. So what I'm first going to do is I'm going to solve this one for y, which will mean adding x to both sides. And when I do that, I get an equation of y equals x. Then I know that y is equal to x, and that's where I'm going to substitute in my value. So step 2 is going to be that instant of substituting into the other equation for that variable and then solving for that variable. So now I will go and use that first equation. So I have 2x plus y, but y equals x, so I'll put that x in, and that is equal to 6. So when I solve this, 2x plus x is 3x equal to 6. And when I divide by 3, I get x equal to 2. Scrolling up a little bit here, step 4 is substituting into the original equation your solution and solving for the other variable. So now I need to take that 2 that I got for x and put it in to the original equation of negative x. So I have negative x, which is 2, plus y equal to 0. Add 2 to both sides, I get y equal to 2. So my solution here should be written as an ordered pair because this is the point of intersection, which is at the point 2, 2. However, our final step is going to be to check your solutions, and this is very important to do because sometimes you think you did it right and one small error could create a problem for the whole thing. So if I put in 2 for x and 2 for y, 2 times 2 plus 2 is 6, and negative 2 plus 2 is 0. So therefore I know that I did it correctly. Moving on to the next example. In this particular problem set of equations, when I look at this, I like to highlight the one I'm going to solve, and this first one to me lends itself a little bit better because that y has a coefficient of 1. So I'm going to go ahead and solve that one. So 2x plus y equal to 3. I'm going to subtract 2x from both sides, giving me an equation of y is equal to negative 2x plus 3. So now I'm going to put that into my second equation, and this is why highlighting the one you solve for comes in handy to make sure you don't plug it back into the original equation. So now I've got 3x minus 2y, which y is negative 2x plus 3. And this is equal to 8. So then I use my distributive property, not forgetting that this negative sticks with the 2. So I have 3x plus 4x minus 6 equal to 8. 3x plus 4x is 7x minus 6 equal to 8. We'll add 6 to both sides, giving me 7x equals 14. Divide by 7 and we get x equals 2. So then I can go ahead and put that back into the original equation of 2x plus y equal to 3. And I get 2 times 2 plus y equal to 3. 2 times 2 is 4, so I have 4 plus y equals 3. Subtract 4 on both sides, and I get y equals negative 1. So my solution is 2, negative 1. And when I go back to check that, I know it works in the first one because I just did it. And 3 times 2 is 6. 2 times negative 1 is negative 2. 3 minus negative 2 is 6 minus negative 2, which is 6 plus 2, which is 8. We know that is correct.